NASA may be about to do something that sounds like a rejected Star Wars side quest. Take a Mars rover and send it to the moon. And not just any rover. NASA is looking at Promise, a fully functional engineering cousin of Curiosity and Perseverance, originally built at JPL to help engineers test commands before sending them to Mars. Basically, it's the stunt double. And now NASA is asking, what if the stunt double gets its own movie? That sounds simple, right? A rover is a rover. Wheels, cameras, robot arms, science gear, space vibes. Just drop it on the moon and let it roll. Except, Mars and the moon are not just two dusty rocks with different Instagram filters. Mars is a cold desert planet with thin air, red dust, gravity that's about 38% of Earth's, and a day that's conveniently close to 24 hours. The moon is a vacuum-sealed nightmare sandbox with razor-like dust, brutal temperature swings, weird lighting, long darkness, lower gravity, and no atmosphere to help cool anything down. So the real question isn't, can a Mars rover drive on the moon? The real question is, can NASA turn a machine built for one alien world into a survivor on another? Before we drill down into the engineering madness, do me a quick favor. Hit subscribe, tap like, and drop a comment telling me this. Would you rather drive a rover on Mars or be the first person to get a speeding ticket on the moon? The algorithm enjoys commitment issues, so every click helps. Alright, so here's the thing. Imagine you built a pickup truck for the Arizona desert. It's rugged, tough, heat-tested, dust-tested, ready for rocks. Now, someone says, cool. We're sending it to Antarctica at night with no air, on a beach made of broken glass. That's basically the Promise problem. Mars rovers are engineering legends. Curiosity landed in 2012 and just kept going. Perseverance landed in 2021 and started doing what amounts to robotic field geology while carrying a tiny helicopter that somehow became one of NASA's greatest flexes. But those rovers were built around Mars. Mars has an atmosphere. Thin, yes. Pathetic, yes. If Earth's atmosphere is a warm blanket, Mars has a wet napkin, but that wet napkin still matters. It affects temperature, dust behavior, entry and landing, and thermal design. The moon has no real atmosphere, no wind, no weather, no blue sunsets, no help. If a rover heats up, it can't dump heat into air because there is no air. If it gets too cold, there's no environment buffering the temperature. It's just sunlight, shadow, and physics sitting in the corner being smug. And then there's the dust. Classic sci-fi gives us smooth silver moon bases and astronauts bouncing around like happy kangaroos. Reality gives us lunar regolith, tiny, jagged particles created by billions of years of micrometeorite impacts. On Earth, sand gets softened by water and weather. On the moon, dust doesn't get a spa day. It stays sharp. Apollo astronauts hated it. It stuck to suits, scratched surfaces, got into seals, and smelled weird when they brought it back inside the lunar module. Now, imagine being a rover with joints, wheels, motors, cables, sensors, and mechanical parts. Lunar dust is not cute space powder. It's the moon's glitter. And like glitter, once it gets everywhere, it has declared permanent residency. So why even try this? Because Promise has one enormous advantage: power. Most lunar robots depend on solar panels. That's fine until the sun goes away, which on much of the moon can mean roughly 2 weeks of darkness. At the South Pole, the lighting is complicated. Some ridges get long periods of sunlight, while nearby craters sit in deep shadow, potentially hiding water ice. Promise, like Curiosity and Perseverance, uses a radioisotope thermoelectric generator, or RTG. That means it turns heat from naturally decaying radioactive material into electricity. No, it's not a mini nuclear reactor. It's more like a long-lasting thermal battery with a very serious resume. That's huge on the moon. An RTG doesn't panic when the sun sets. It doesn't care if a crater is shadowed. It can provide steady power and heat, which means Promise could explore places that solar-powered rovers might treat like a haunted basement. And those shadowed regions matter because water ice near the lunar South Pole is one of the biggest reasons everyone suddenly cares about the moon again. Water is not just for drinking. Split it into hydrogen and oxygen, and now you're talking rocket fuel, breathable oxygen, industrial chemistry, and long-term survival. In space terms, water is not a resource. It's a cheat code. But getting to that cheat code is messy. The lunar South Pole isn't a flat parking lot. It's rugged, sloped, cratered, and lit like a badly designed horror movie. Low sun angles create long shadows that can trick cameras and sensors. A rock can look like a cliff. A shadow can hide a wheel-killing obstacle. A crater rim can be a scientific jackpot or a very expensive trap. Mars rovers already deal with delayed communication. You don't joystick them live like a video game. Engineers send commands, the rover executes carefully, and everyone hopes the robot doesn't choose violence against a hidden rock. The moon is closer, so the communication delay is way shorter. That's good. But NASA doesn't want a rover that needs constant babysitting. If we're building a lunar base, robots need to scout, map, inspect, and maybe help prepare infrastructure without humans micromanaging every inch. That's where modern autonomy comes in. JPL has also been testing new rover ideas, like Ernest, a prototype built to handle rough terrain with smarter mobility. It can move faster than classic Mars rovers, use active suspension, steer in different ways, and adapt its wheels to difficult ground. That matters because Perseverance and Curiosity are brilliant, but they're not exactly speed demons. They move like they're carrying a tray of soup through a room full of cats. That cautious style made sense for Mars. But if you want a science road trip across the moon, as JPL scientists have described it, you need mobility that's faster, smarter, and more flexible. Promise could become a bridge between old-school rover reliability and new lunar ambitions. But there's a catch. Promise is not just sitting in a garage waiting for a vacation. It's useful on Earth. Engineers use test rovers to troubleshoot problems for active Mars missions. If something weird happens to Perseverance or Curiosity, you want a similar machine on Earth to test solutions before uploading commands across interplanetary space. Sending Promise to the moon means giving up that safety net. That's not a small decision. It's like NASA saying, "This spare key to our Mars rover program? Let's launch it to another world." Bold? Yes. Insane? Maybe. Very NASA? Absolutely. And history gives us a warning label. The Soviet Union landed Lunokhod rovers on the moon decades ago, and those machines proved robotic lunar driving could work. But Mars has been far less forgiving. Early Soviet Mars landers struggled badly, and Mars 3, which carried a small rover, stopped transmitting shortly after landing. Space robotics has always lived on the edge between genius and disaster. Even today, lunar missions are rough. Landers tip over, engines kick up dust, navigation systems get confused. A tiny mistake can turn a billion-dollar robot into modern art. That's why NASA is moving step by step. Landers, drones, rovers, payloads, tests, failures, upgrades, repeat. It's not as glamorous as planting a flag, but it's how you build a civilization off-world without speed-running a catastrophe. So, will a Mars rover work on the moon? Yes, but not by accident. It'll need modifications. Thermal systems have to handle harsher extremes. Software has to understand lunar lighting and terrain. Wheels and mechanisms need to survive dust that behaves like microscopic sandpaper. Operations teams have to rethink driving strategies, and every system has to be checked for a world with no air, lower gravity, and a personality best described as hostile minimalist. But the deeper answer is this: Promise doesn't have to be perfect to be important. If it works, NASA gets a nuclear-powered scout for one of the most valuable regions in the solar system. If it struggles, engineers learn exactly what lunar surface systems need before humans depend on them. Either way, the moon becomes less mysterious and slightly more manageable. And that's the real story. This isn't just about one rover. It's about whether humanity can stop treating space exploration like one-off heroic camping trips and start building systems that last. The moon is the test range. Mars is the bigger dream. And machines like Promise are the awkward, brilliant, dust-covered middle step between footprints and a future where humans actually live beyond Earth. So yeah, a Mars rover might work on the moon, but the moon is going to make it earn every inch. Stay curious, fly smart,